Welcome to another home delivery in English about the program Journey Through the Universe. Last time I promised you to do the ice giants, and that's why you already see one of the ice giants, the closest one to the Earth, the seventh planet of the solar system, Uranus, in the background. Why am I pronouncing it Uranus, which sounds more German? If you try the English version, you always get quite a lot of laughter, and so astronomers try to pronounce it Uranus and not the other way around. I'm not going to mention what it is. But because we are at the name of Uranus already, it's special because it's the only planet which has a Greek name and not a Roman name. The Roman name of the god Uranus, which is the father of Saturn, and Saturn is the father of Jupiter, would be Zeus or Zelos. And it's a not very well-known god, but about the name of Uranus there's something else. Uranus was discovered by William Herschel, a German who lived in the south of England and built his own telescope. And with this, he suddenly noticed that there is a star. He thought it was a star, but he found it was moving. And because he and especially his sister Caroline kept very close charts, they then found out a little moving dot. This has to be a planet. And to honor his king, he first called it George Star. The king which was reigning the UK was George III. But there are only god names in the heavenly bodies, especially in the solar system. And so then it was considered if they may name this new planet Urania. But it was decided Uranus is the new name. Because we are at names already, another specialty of Uranus is its moons don't have Greek or Roman names. They are named after characters of Shakespeare. But there are 27 moons, by the way, but at first we'll start what is an ice giant. Because we have 4 gas giants in the solar system: Jupiter, Saturn, Uranus, and Neptune. And very soon, in around 1940, they discovered that the consistence of Uranus and Neptune is very different to Saturn and Jupiter, because Saturn and Jupiter consist of 90% of hydrogen and helium gas, and only in Uranus and Neptune it's only 20%. They mostly are made of ammonia, methane, and water. The outer layer, the atmosphere kind of, is hydrogen with methane. And this also causes the blue color, because methane absorbs red light and reflects blue light. As you notice, Uranus has rings. Here in deep space, they are very well visible. If you try to look at Uranus with a telescope, you will find them much harder to distinguish, because they consist not of ice particles like Saturn's ring, but mostly of dust. So they are rather dark. When the first probe went by Uranus, Voyager 2, the first and only probe which went by this planet, it was not certain if there would be rings, and they discovered even more rings, and then they discovered 11 moons. Now we know Uranus at the moment has 27 moons, but when they came closer, Uranus was rather boring. It was just blue and not very spectacular, and it didn't have those white stripes which you see here. So they were disappointed. Also, the magnetic field was not as spectacular as they hoped it would be. But when they moved to the other side, suddenly they got the radio signals of the magnetic field, because Uranus and Neptune don't have a normal magnetic field. They have 2 north poles and 2 south poles, and on the side pointing away from the sun, we have the sun now over on the left side. Maybe you notice how small it is if you're out there. The distance from here to Uranus is 2 hours 40 minutes. And on the back side they had strong magnetic signals. Uranus' magnetic field is a quadruple field, so as I mentioned, 2 north and 2 south poles. By the way, this is the pole. This is not the equator, this is the pole, because Uranus is tilted around a little more than 90 degrees. And so it's kind of rolling along on its orbit. The reason why this is so is not clear. Some scientists think it crashed with one of the protoplanets. Even some think it was one is not enough. It has to be 2 protoplanets. But others think because it's very likely that Uranus and Neptune switched places, that maybe when Neptune jumped over Uranus, that Uranus tilted on its side. But it's not proven, that's just a theory. Normally, if we zoom out, we get the orbits of the moons, but not with Uranus. I don't know why. Maybe because they are really, really tiny. As I mentioned, they are all named after characters of Shakespeare plays. The most well-known are Miranda, Titania, Umbriel, Ariel. But the 5 biggest moons of Uranus are only not even half the mass of Neptune's biggest moon, which there's the hint. We are jumping to Neptune now. And Neptune's biggest moon, Triton, which we'll see and hopefully see in a minute, has twice the mass of 5 of the biggest moons of Uranus together. How the moons came about is not certain. How the rings came about is not certain. And if maybe you can see these tiny, tiny lines here. This gives you a hint about the rings of Neptune, because all of the gas giants have rings, even the 2 ice giants, but they are not visible in normal telescopes. Only when Voyager 2 passed by, they found the rings. Here, as you notice, you see the moons. Neptune and Uranus are very, very similar. They are kind of twins, but Neptune has 70 times the mass of the Earth, whereas Uranus only has 15 times the mass of the Earth. So Neptune is heavier. It's also the 3rd biggest planet. Uranus, even though it's closer to the Sun, is only the 4th biggest planet. Okay, so now we're trying to find some of the. By the way, Uranus and Neptune have seasons. The seasons on Uranus last 21 years. The seasons on Neptune last 40 years, and it takes Neptune 165 years to do 1 orbit. And here we can see Neptune's biggest moon. You see it is in retrograde motion. Neptune is spinning in this direction. 1 day lasts 16 hours. And Triton is moving in the other direction. Triton is 2,700 kilometers in diameter. And if people would sit here in deep space, what I would do now is shoot the moon through the audience, which is always a very big success. Now I'm moving it back so we can take a little look at it. It's most likely a Kuiper belt object which has been caught by the gravity of Neptune. It's a very, very interesting object because it has cryovolcanism, means there are volcanoes active on Triton, and it is also the place where the coldest ever measured temperature has been measured, 235 degrees minus Celsius. But I mentioned before the ice giants, yes, they are cold. Neptune has minus 220 degrees on its surface, but the name comes from the different consistence, not hydrogen, but methane, ammonia, and water, and not because of the temperature, which is, of course, rather low. But inside, those giants they think Neptune is 7,000 degrees Celsius in the center. They think it has an iron core, and they think the magnetic field is so strange because it starts existing not in the core of the planet, but in outer layers maybe, but they can't be sure. So now I'm zooming out. Because the category ice giants was created because of Neptune and Uranus, but there are also exoplanets, extrasolar planets, planets circling around or orbiting around stars and not around the sun, our sun. By the way, because we see the orbits of the planets here, this distance from here to the sun would be 4 hours 10 minutes, and this is 2 hours 40 minutes. Means that each signal from here to the Earth takes at least 4 hours, and at best 2 minutes, and at worst almost 4 hours 20. But now we are moving out, and we are taking a look at the exoplanets. You see the constellations, they look the same as everywhere in the solar system. Now we left our solar system, and now you see stars being circled where they know there are exoplanets. We already found over 4,000 exoplanets so far. As it looks, exoplanets are normal with star formation, and almost every star has an exoplanet. And with this, I'm going to end this program and give you a little preview about something which I'm going to present next week, because next week, okay, I'm working with, now we are in there, and I won't be here with a journey through the tabula Poitingeriana, and it's not working at the moment. I'm trying. Now we're in there, and I.
Ist der Vogelkontakt beim.
So on Wednesday at 4 o'clock there will be the historic maps of the world. 2 maps will be presented Tabula Peutingeriana, which is the replica of a Roman map, and also Ebsdorfer world map, which is in a museum in Lüneburg. And on Thursday, I'll be coming back at 2 and at 4 with this image which you see in the back. And my colleague already enlarged it. This is an image which I did myself. It's an image of the Danube from its origin to the mouth of the river in the Black Sea. And as you see, it's very colored, very colorful, because it's a false color image. Only a part is in natural color, and I'm going to explain what this does. The whole program is called 2,800 kilometers, one river, 10 countries. And with this, I'm going to end the program now. So thank you for your attention, and maybe you tune in to get more information about this Danube image, and also about the two historical maps. Thank you, and bye-bye.